Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. What if you have a pulley and spring combination? There is a very good method to solve the problem of pulley and spring combination, that is replacing pulley and spring with a single spring and finding its effective spring constant. Now consider this pulley and spring. So the spring constant of the spring is K. Suppose the stretch in the spring is X units. So X length is given to the pulley. So x by 2 and x by 2 is distributed on either sides. The pulley would come down by x by 2. So the effective distance that the mass is coming down to achieve equilibrium is x by 2. Now if you replace this pulley and spring system with a single spring, the effective stretch of the spring must be equal to x by 2. The meaning of effective spring constant is, had it been a single spring, what is its effective spring constant, which gives the same effect. So the effective stretch is x by 2. Now draw the free body diagram of this mass. So you have mg down and the tension T up. Now draw the free body diagram of the pulley. So you have kx up and there is T dash, and T dash is also equal to kx if a spring is connected to a string. If a light spring is connected to a light string, the tension in the string and the spring force are equal, because consider this point. So for that point kx is upwards and the tension T dash is down, so T dash is equal to kx. So on this pulley there is upwards kx and upwards T dash, which is also equal to kx, and downwards it is T. So T is equal to 2 times of kx. So T is equal to 2 kx. Now 2 kx is balancing mg. So 2 kx is equal to mg. This is the first equation. So consider a single spring of spring constant K effective. So the spring force is K effective into effective stretch, that is x by 2. That should now balance the load mg. So the equation in equilibrium is K effective into x by 2, which is equal to mg. This is second equation. So both are mg. So equating 1 and 2, 2 kx is equal to K effective into x by 2, x is gone, and K effective is 4k. So if a pulley is connected to a spring, or if a spring is connected to a string which is passing over the pulley, then that pulley plus spring can be replaced with a single spring whose spring constant is 4 times k. Let us see one example on this. Consider the system. We have 3 springs and 2 pulleys. Suppose the block is slightly distant from equilibrium, so the block keeps oscillating, and the pulleys oscillate at their positions. The pulleys will have angular oscillations. If we have to find the time period of these oscillations, it is very simple if you find the effective spring constant. Otherwise, this looks like a very complicated problem. Now, pulley plus spring, I can replace this with a single spring of spring constant 4 times of the spring constant of this spring. So it becomes 4k, and this is connected to now another spring of spring constant 4k. So this is point B and this is point C. As you can see the figure, there is another spring of spring constant k connected to this mass m. Now 4k and 4k are in series. If 2 springs are in series, then the effective spring constant is k1 k2 by k1 plus k2. I have already done a video on that. I'll give the link in the description. You may check that out. Now the effective spring constant of 2 springs connected in series is 4k into 4k by 4k plus 4k, that is 8k. So k is gone, 4 1s, 4 2s, and 2k. So the effective spring constant is 2k. So 2 springs I am replacing with a single spring of spring constant 2k. Now it is connected to the pulley. This is point C, block M. Now spring plus pulley, I'll replace with a single spring whose spring constant is 4 times the value of the spring constant of the spring connected to the pulley. So 4 times 2k, that is 8k, and it is connected to k and mass m. Now this is point C. Now 8k and k are in series, so finally the effective spring constant is 8k into k by 8k plus k, that is 9k. So effective spring constant is 8k by 9. As simple as this. Now if you find the effective spring constant, you can solve many problems related to this model. Suppose if you have to find the time period of oscillation of these blocks or the pulleys, so for a simple spring block system, so you are converting this into a simple spring block system of effective spring constant 8k by 9. So the time period of the simple spring block system is 2 pi into under root mass m by k effective. So I can simply write 8k by 9, as simple as this. If you have any questions or queries or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and receive your feedback. This is Vikram Dachepally signing off. Namaste.